presentation. My name is Anthony Chamont. I'm one of the District 7 safety consultants. As always, I'll give you a quick summary of the presentation website that we have, the Tampa Bay Traffic Safety Local Area Traffic Safety Academy site. If you ever don't receive a link for one of your registered webinars, you can come here. We always update this after the presentation. The link on the page takes you to today's webinar. This is updated on a weekly basis. The links for all upcoming webinars are in here as well. So any of the upcoming ones that you wish to register for, if you have not already registered, you can do that through this page. This page as well, if you go down, has the presentations for all the previous sessions, including the video recording of the presenters giving the presentation for the 2014 and for the 2013 Safety Academy. And the general resources page down below is the PDH request form for the professional development hours if you'd like to get credit for this webinar. And we have other pertinent information that was requested by different people, like District 7's benefit cost and net present value calculation spreadsheet is there. With that, I will hand that over to Dennis. I'm going to make him the presenter for his introduction on the Safety Academy.
Can you see it?
Yes, sir.
Okay. Good morning. My name is Dennis Falloon, and I'm a District 7 Safety Academy Coordinator and a District 7 Safety Consultant. And I'd like to welcome you to the second series of the safety webinar topic of 12 that we have scheduled for 2014. I'd like to do a short introduction about the local agency Traffic Safety Academy put on by District 7. And basically this set of webinars provides information regarding your local safety-related issues to enhance your safety programs. They began on March of 2014, and they usually run between 10 and 12 o'clock, and they're about 2 hours. Normally they're a little less than that. And then also there are various websites that you can register for the Safety Academy. Then there's the website for the Traffic Safety, which has what Anthony was talking about, all the information related to prior presentations and recordings. And so you can go to those sites and get that information. And today's presentation will be fundamentals of traffic control devices. And our presenters will be Raj Pantalara, who is with the FDOT. All these folks are with FDOT in Tallahassee. He has over 19 years of experience in traffic engineering and operations and ITS. And Christopher Lewis, who has 5 years of experience in roadway design, construction, maintenance of traffic with FDOT. And Angela Wilhelm, who has over 9 years work experience in traffic engineering and access management with FDOT. As Anthony mentioned in the very beginning, you can get credit, PDH hours, for those that are PEs. And this is the information for that. That's also out there on the website. And you can go to that website that he mentioned, and that is where you get the form. Also, we just want to mention that the AICP hours are still being approved, and you'll be able to get those out on the website for that. And the third series of topics are currently being worked on. And finally, if you have any questions, need any assistance with the Safety Academy, you can contact me by email or by phone. And with that, I'd like to turn it over to Raj and his folks.
All right, I will switch presenters here. And if anyone has any questions during the presentation, please type them into the chat, and we'll do our best to answer them along the way. We try to keep it, relatively informal. It's a two-way conversation.
Assuming y'all can see our screen now. Can you all see our screen, Dennis?
Yes.
Yes.
Okay.
Great.
All right. Well, Dennis, Anthony, I appreciate the introduction. This is Chris Lewis, by the way. Again, we'll be covering the fundamentals of traffic control devices, myself, Angela, and Raj. And Dennis, I want to give you thanks. I haven't sat for my PE yet, but I do like the initials there at the end. It looks good. So that's my goal in the future. So with that said, we're going to talk about fundamentals of traffic control devices. Quick look at what we're going to break down as far as an agenda. We're going to cover signs, talk about some of the manuals and the guidance the department puts out. We'll talk about some of the administrative code. Pavement markings, Angela's going to talk about that, give you some information where we're headed with that, and then Raj will wrap up with some signal discussion at the end. And then we'll take any questions. I think Dennis and Anthony all told the audience we can kind of take questions as we go through this. So if there's anything really, we can stop and answer and have a little open discussion. Right here, this is just the link to our webpage, Central Office Traffic Operations website. And here's another link. This takes you to our documents. At this link, this is where our traffic engineering manual is. Our Florida Administrative Code, and any of our traffic operation bulletins, anything as far as documentation goes dealing with traffic operations, hence going with our traffic control devices. Florida Statute 316, 0745 talks about uniform signals and devices. Basically, this covers, talks about how the department adopts a uniform system of traffic control devices for use on the state highway system. Within this, we talk about how we will publish and supply a manual for uniform traffic control devices defining system adopted, uniform system adoption. We also talk about devices and how to be purchased and installed on a state public road system. And we can talk about, and I'll mention this in another slide, but how we can permit traffic control devices that are non-conformity to our standards or our guidance.
Raj? Okay. Yeah, this is Raj Panluri. I'll jump in real quick on this one slide, and then Chris will continue with the next slide. This particular slide talks about the Code of Federal Regulations, and we often get the question on why we use the manual on uniform traffic control devices. And we always say that it goes back to the Federal Highway Administration's mandate, which talks about the adoption of new or revised national MUTCD as a standard for traffic control devices in the state. In other words, 23 CFR gives 3 specific options for states to choose from. And Florida DOT has selected the first option, which is to essentially take MUTCD as the guiding document. So whenever we get citizen concerns or citizen questions or even regular traffic engineers, we always refer back to the MUTCD. Even though we have the traffic engineering manual, the manual on uniform traffic studies, the speed zoning manual, etc., and we'll touch on those later on. But the bottom line is MUTCD is the guiding document with respect to all the traffic control devices that are used in the state.
Thank you, Raj. Yeah, and as Raj said, the manual for uniform traffic control device, this is kind of our adopted manual. It's where we're published Federal Highway Administration, published by the Federal Highway Administration. This contains all national design applications, standards. This is kind of the paving for any traffic control devices that we use. Now, Florida does go above and beyond with some special guidance and criteria, and we'll mention some of that stuff within our traffic engineering manual, some of our rules, and some of our design standard index in other slides. By definition from the MUTCD, traffic control device is a sign, signal, marking, or other device used to regulate, warn, or guide traffic placed on, over, or adjacent to a street, highway, private road, open to public travel, pedestrian facility, or shared use path. So we will do our best to kind of break that down into the 3 areas, signs, pavement markings, and signals, and give you kind of an overall perspective of what those are. And I think Angela's going to mention some more information on this.
Yeah, so we get a lot of requests for traffic control devices on state roadways. The local agencies do as well. And according to the Manual on Uniform Traffic Control Devices, in order for these to be effective, they've got to fulfill 5 basic requirements. And those are that the traffic control device must fulfill a need, command attention, convey a clear and simple meaning, command respect from road users, and give adequate time for proper response. So as I mentioned, we may field a lot of requests from folks who've got real good intentions about installing new traffic control devices along roadways that they think might make the road safer, but really if there's not a need that we're fulfilling there, or if we're not conveying a clear message, those traffic control devices may not be effective and may not have that effect of improving safety on the roadways.
All right, thank you, Angela. This is one of our documents that we publish from the department side, Traffic Engineering Manual, also known as the TEM. The purpose of this is to provide traffic engineering standards and guidelines to be used on a state highway system to our designers. I did a presentation on this back in July, or the Design Expo, and kind of gave a 101 on what the TEM was. I learned quickly when I joined the department that I didn't know what the TEM was, so coming from the design side, I had a feeling that it would just be a good exposure point at that time. So we did a little 101 session then, and we'll probably do some more in the future, but this is kind of where we hold our guidance for traffic operations. And also, I think Raj is going to help me tag team this. This is where we get to talk about our products and what we allow out there on the state highway system. All traffic control devices that are installed on the state highway system, as far as material now, has to go through, proper testing and meet specifications and be listed on our approved products list, which I think we still kind of call it the qualified products list also. Right, correct, Raj?
Yeah. If I can add to what Chris just mentioned, we have the Traffic Engineering Research Laboratory, or the TERL, T-E-R-L, that is a part of the Traffic Operations Division here in Tallahassee. It's a pretty intense laboratory where all kinds of experimentation is done before any device is approved for use in the state of Florida. So any traffic signal you see, any all the material that is used on signs and payment markings, everything is more or less approved and becomes a part of the APL. Now, there may be situations where a new vendor may come up with a specific product, say for the wrong way incidents. We've been hearing a lot about wrong way crashes of late. We do have several vendors who want to showcase a particular product for application. When such a thing takes place, as a temporary aspect, the TERL office will do all the testing and then may decide, I repeat, may decide to approve a permit for testing the device at a specific location for a specific application. But that may not be on the APL, but then it is through a permitting process. All said and done, almost all the devices you see out there with large-scale application are a part of the APL, the approved product list.
Correct, and that language, as Ross was describing as far as the permit, that goes back to the statute 316-0745. Sorry, that's not me, sir. Okay. All right, signs. Kind of jumping into the agenda, the meat of the agenda. Part 2 of the METCD talks about signs. These are broken up into quite a few sections. I'll do my best to kind of give a basis as to all these. And again, if there's any questions on any of this stuff, stop us. But this is kind of the starting ground for the department and how we come across with our guidelines for the Traffic Engineering Manual and also for the Design Standards Index, as far as any kind of signs and anything we're putting out there on our state highway system. And it's not just limited to static signs. We also deal with dynamic message signs, portable changeable messages, and so forth. Next slide. Okay, and definition of a sign from the METCD is any traffic control device that is intended to communicate specific information to road users through word, symbol, and/or arrow legend. Signs do not include highway traffic signals, pavement markings, delineators, or channelization devices. So there is a difference. Like I said, the METCD kind of breaks it up. I called it subchapters. I didn't know if there was a better terminology for it, but there's 13 of them. It talks about regulatory, warning, There's 2 sections on guide signs, one conventional roads, freeways, and expressways. Toll road signs, preferential managed lanes or managed express lanes would be an example. General information, general service. We get into logo. TODs or tourist-oriented directional signs. Changeable messages, as I mentioned earlier. Recreation, cultural interest area, and emergency management. Within those areas, the department does a good job as far as we kind of condense that. We have a Ford Administrative Code, and I've got a slide on that I'll kind of bring up, but that's our state highway signing policy, and I think it's 5 parts, or yeah, 5 parts. We have limited access, non-limited access. We talk about place name signs. We talk about wayfinding. We talk about our TODS program in there. As far as regulatory warning, regulatory and warning signs, we do refer back to the MUTCD on that. We don't get real specific as to anything, I guess, proprietary to DOT as far as anything we put out for that. So that is a national thing we go by. All sign placement, installation purposes, that's all done to the MUTCD. We don't have any specific information as far as anything extra we produce for that stuff. Jumping into the traffic engineering manual, chapter 2 of the TEM is our signing chapter. Within there we have, I want to say close to 37 sections. I know it goes from 2.1 to 2.40, but I mean there are some sections in there that are skipped, or we've got some blanks in there that we allow for future sections to come in. This is anything that is non-conforming to the MUTCD. So anything specific to Florida's roadway, we develop it. We'll put it out there on our sign library, which is under our traffic engineering website, as you saw at the beginning. We'll have the examples out there, and we have the guidance within our traffic engineering manual. And whenever we create new sections or we update these, we have a mailer list. We're always sending out updates. I'd be more than happy to add anybody to it. It's a good thing to be on. I know coming from roadway and construction area, I wasn't aware of all of it before, so it is a good place to have, be in contact with. Just going through it briefly, I'm not going to hit all these sections because that would probably take up Raj and Angela's time and everybody else out there listening. But we, jumping from some of these, we have overhead street name signs. We get into specifics as far as font size, sign dimension restraints. We talk about our internally illuminated within there, kind of skipping down. We have our guidelines for bicycle warning signs. I know we're doing some revisions to that. That's just going to become guidelines for bicycle signs. We're adding some language and some sign details there. Next slide. I mean, you can see this. The list in this here in this section just goes on. I will kind of give you one update we just recently did. Reference location signs, otherwise known as mile markers. That was broken up before. We used to have a section called call box mile markers. Well, the state, FDOT, we did away with call boxes, and we took the chunk of mile marker language out of there and we combined it with another one, and we were able to bring in some more guidance from the MUTCD specific to our roadways as far as enhanced reference markers. They're in the MUTCD, but what we did was we defined where to use them and when to use them. For example, within urban sections, we post them every half mile versus rural areas every 1 mile. So that kind of guidance is laid out in the TEM in those sections. And of course, going to the end of it, and we're always adding to this. This is not like some of the other manuals you might be used to, PPM, Florida Green Book, which are updated annually. This can be updated on the fly. That's the great thing about the traffic engineering manual. And again, it's guidance. If you're going to, I guess, use this or participate with this language, there's shalls and shoulds in here. So if you do use these sections to the extent, make sure you're following the verbiage in there. But again, like I said, I would encourage anybody, if you're not on the mailer list, please get on it. You can email Raj, myself, Angela, or contact us here, or I'm sure Dennis that has our information. We'd be glad to add you to that list. Okay, and like I mentioned, coming off of the MUTCD, we have a Florida Administrative Code, Rule 1451. This goes through a rulemaking process. We are currently in there right now from last year. We did an update to it. We did several updates to it. But you can see the layout and the breakdown for it. We've got major revision, overall review of this last year, and like I said, it's going through the December, and it should it'll complement some of our other manuals within the department. For example, the plans preparation manual. We took some language from here and we might have placed it there. So stuff like that. That's how we handle our signing program here within Central Office. And just kind of wrapping up sign. Who can request a sign? How do these get out there, make their way out of the state highway system? Local municipalities, politicians, the public, and state agencies. Just for example, I mean, state agencies, we deal with DEP a lot. They've got a lot of state parks. So we are a big partner with them. Some definitive language in our TEM and within the Florida Administrative Code 1451. Public, I get a lot of requests from the public. I know Raj, I don't know if he's going to talk about it, the wrong way stuff. I mean, we deal with the wrong way signs. So, I mean, that stuff, we get all kinds of feedback. So we're always open for information. We're always open for requests. Any way we can improve, that's our number one goal is safety. So definitely, if anyone's got any issues or questions on signing, please contact me. And with that said, I think Angela's going to talk about pavement markings.
All right. Thanks, Chris. Yeah, so we'll move into pavement markings. As you guys can see on here, we've seen some examples of pavement markings that get installed poorly. Oh, pardon me. Does someone have a question?
Dennis or Anthony, did we hear a question or anything in the background?
No, there are no questions presently in the chat.
Okay, thank you. Sorry about that. Oh, yeah.
No, we may have just heard some feedback.
Yeah, I did, yeah. Okay.
All right. So, yeah, as I was mentioning, we've seen some examples of when pavement markings get installed poorly, and so in an attempt to prevent this and avoid some mishaps like we see in this picture, we've got some standards and guidance to help us ensure that they are installed appropriately. So we've got the MUTCD, which covers pavement markings in Chapter 3, the traffic engineering manual that Chris covered. He talks about the sign portion, but if you move to Chapter 4 in the TEM, that'll cover some pavement markings. And then we've got DOT design standards. Our standard indices in the 17300 series have a few that cover pavement markings as well. And those three really provide, the TEM and the MUTCD provide some guidance on the selection of appropriate markings. And then the index provides some guidance on the design, where the specifications provide some guidance on the type of materials and installations of those pavement markings. I would note that it's really important that traffic control devices work together to promote a consistent message to users. So signs and pavement, while we're covering them separately, really they do work together to make sure that we're providing consistent message. And then I'll also note that the DOT Design Office is working on a possible pavement guide that could combine a lot of this guidance into a single location. So keep an eye out for that in the future. If you've got questions about it, feel free to let us know, and we'll get you in touch with the right folks that can give you information. Oh, so yeah, Raj just asked if I want to elaborate on the school. Yeah.
Somebody may think that we put it by accident.
No, yeah, that was the example that I gave of when they may go in inappropriately, and hopefully this was just a mistake and not somebody trying to put the cool in school or something silly like that.
And of course, this was not on the Florida State Highway System.
Correct. This is just on the Google system. So, all right. So moving into the MUTCD guidance. There's some guidance. There's a lot of good guidance in the MUTCD. I'm just going to highlight a couple items here. The colors of pavement markings. Right now, the only colors that are approved are yellow, white, red, blue, or purple. And black can also be used in conjunction with some of these colors to provide additional contrast. And we've also added green for bike lanes. Sorry, that wasn't included here in the slide. You know, in general, most folks know that yellow is going to separate opposite directions of traffic. White will typically separate traffic in the same direction of flow. Red you may see in one-way conditions where it's a do not enter. Typically we'll use those in the RPMs where one side is red facing the wrong way traffic. Blue we use for disabled parking and also with RPMs near fire hydrants in the state of Florida. Purple is typically used in preferred unmanaged lanes and toll lanes. There are some in South Florida pavement markings in addition to then likely be included in the I-4 Ultimate project in Central Florida. I'm not sure in the Tampa Bay area if we've got the managed toll lanes in that area.
Right. And I was just going to highlight the black just being for contrast markings.
Right, so we've got some lighter pavement and the white doesn't show up as well. We'll typically use black for contrast either as a border around the white or as a shadow. There's a couple different applications. So then moving to the next slide, we've got an example of some striping guidelines that are located in the DOT Standard Index. These are outlined in the special markings area. Most of the striping that we see here is about 6 inches wide. We've got double lines. They're separated by a 4-inch gap. The 2-4 skip that you see over on the left side is typically used through left turn path at an intersection. The 1030 skip on the bottom left is typically just a standard lane separation when you've got 2 lanes with that lane. The white skip line doesn't look like it's 10 feet long and 30 feet between them, but it certainly is. The 610 skip up on the right side is used usually across turn lane tapers, and then the solid white is seen approaching stop bars at signals. That 3-9 skip in the bottom right corner, or sometimes it's called the dotted line in METCD applications, can be used for lane drop at interstates to distinguish a lane that's being dropped from a normal exit ramp. Usually those are in locations where we've got at least a half mile in advance of that theoretical door that we can apply that. But in general, pavement markings can be an effective way of visually guiding drivers through their path. So you may just have, if you're looking at a road without any pavement markings, you've got a whole bunch of black, typically black asphalt, but adding those lines can really provide the guidance to drivers as where they need to be. We've touched on this a little bit, but if we're going to apply any non-message, those need to go through a request for experiment process with central office, that's our office up here, engineering and operations, and the Federal Highway Administration. Our office works with the district to apply for these. I know in the District 7 area, we've got one right now. We're waiting for approval on the red rectangular. Oh, we did receive this. It's just in. We have approval for the flashing do not enter sign to prevent some wrong-way crashes. So really that's the process for evaluating the effectiveness of any new device. Typically, those also require a before and after study to ensure that they appropriately. Relating this back to pavement markings, we've also got, we're looking at an experiment with in-road red wrong-way arrows up in the Panhandle area as well. So with that, I'll go into a little bit of detail about the types of pavement markings that we use here at the department. The several slides that I'll go through have been adapted from material that was presented by the DOT Design Office. If you've got questions, feel free to type them in or hold them to the end. We'll see what we can do to answer those. So we've got several different types of markings that we can select from. So in the next slide, we'll just touch on some of the considerations that apply to all markings. And really those refer back to visibility. Pavement markings can't really provide information to drivers if drivers don't see them. So When we're considering the visibility, we also want to consider the lighting, so nighttime, and also weather. Some types of pavement markings aren't as visible in other wet conditions. And we're going to go back a couple. Sorry about that.
This one?
Sure, that's fine. The other item is color, and as we discussed earlier, color can convey meaning. Thanks. Now we're back on track. There are several different types of reflectivity. The one that we talk about mostly when it comes to signs and pavement markings is retroreflectivity, which really just means that when the light hits the surface, it reflects back to the driver's eye, or back to the source of where the light came from. So one of the techniques that we use in our pavement markings is adding beads to the pavement markings to help increase that reflectivity and visibility in certain conditions. So some of the types of pavement marking materials that we have are paint, thermoplastic, preformed thermoplastic, high-performance tapes, which we're not really going to touch on too much here, and audible and vibratory markings. So we'll cover a few of those options for pavement markings here. The first will be paint. We're all pretty familiar with how paint works. It's a common household item. We paint our houses, we paint other things, we paint roads. Unfortunately, it doesn't hold up as long as some of the other types of markings that we've got and other materials. So in the next, we'll talk about some of the primary uses. Because paint markings get run over all the time, we want to make sure that they've got a long enough life that we're not out there repainting the surface of the roadway regularly. So paint's got a shorter service life than some of our other types of markings. So for that reason, we'll use it for short-term projects like maintenance of traffic and some contrast. As I mentioned, some of the limitations include the service life and the visibility. When you're in wet conditions, it can be tough to see paint. The next material that we'll cover is the thermoplastic, which is probably one of the more common materials that we use on our roadways. It's got a higher reflectivity. It's applied super hot. I think it's over 400 degrees. We've got to heat that up when we're binding it to the pavement. So we also include glass beads in the thermoplastic which contribute to the higher reflectivity levels. And as I think logic tells us, better visibility leads to improved safety, so that these can be effective. Other uses of thermoplastic include the edge lines, lane lines, and stop bars, also messages and symbols. Kind of touched on the advantages of thermoplastic over paint. It's got a longer service life, higher reflectivity. You can see it better in wet conditions. One of the challenges that we have is that it doesn't bond well to concrete if moisture is present. So from regular thermoplastic, we'll move forward to preformed thermoplastic, which you can kind of think of these almost like big stickers that come preformed, and we apply them. We'll heat them up and apply them to the pavement. So we typically use them for applications such as the exit ramp numbers, bike symbols, crosswalk markings, and pavement messages. We've recently added a section in the traffic engineering manual, section 4.2. Do you want to touch on that, Chris?
Yeah, we're currently updating 4.2. I can tell you what the old title was. It was before I got here, but it was very long and convoluted. We shortened that, and we've added some language in there on route shields, pavement markings. So look for that to come out probably within the next month or so. It'll go hand in hand with some spec changes and some other, I think some design standards might be updated along with it over in the roadway design office. But yeah, that's a new section. It's not a new section, it's just a new revision to that section, and it's got some detailed information in there. It kind of talks about some standards from METCD, but then again, we get back to that specific knowledge or information as far as what we want out there on the state highway system for Florida. So.
Great, and along that line, there's currently been some research going on related to elongated pavement markings and their effectiveness.
Yes. Yeah, we've looked at some research from TTI, and I know Raj and I have reviewed some reports on that in the past, so we're still reviewing that.
All right, one of the other options that we've got for materials is permanent tape. which are typically used for the center lines on concrete. One of the benefits is that they do perform better on concrete than thermoplastic will. We can go to the next slide. We'll just touch on some of the advantages. They've got that good reflectivity. They're a little bit more expensive. They perform best on concrete, but because they're more difficult to install, they require a little more preparation when we're installing the tape.
And you'll see a lot of these on bridges and that sort of stuff. So, and like Angela said, anywhere where there's rigid pavement throughout the state highway system, which I think we did some numbers the other day. We're under 200 lane miles of concrete or something like that.
Wow.
It's not a lot. So, but just a little more information on it.
Yeah, great, thanks. All right, and then the last type or material for pavement markings that we'll cover here is audible and vibratory markings, which are often applied to promote safety. In locations where we've got lane departure crashes, they can be effective in reducing lane departure. Somebody maybe isn't paying attention or dozes off. As they cross that edge line, the audible marking will physically make the car kind of boom. They hear it as you cross that line and get people to pay a little more attention. Typically, some of the uses that we've applied up to this time are in rural two-lane corridors for these markings. Some examples, there are 40 in the Ocala Forest in District 5, and I read somewhere that District 7 has over 150 miles of audible and vibratory markings. So we're applying them in the Tampa Bay area as well. Typically, they're used for edge lines. It can be used for center line markings if we've got a series of head-on crashes. Some of the limitations, we don't want to use them on taper areas or locations where drivers are required to cross just because they make noise, and we're trying to use them for deterring drivers from crossing them. So I just want to show you a couple options that we use. On the left, you'll see some of the ground-in rumble stripes, as we call them, versus the raised type on the right, which are sometimes called cookies. So we've got some that are depressed and some that are raised. I believe that the DOT Design Office is working on language for further implementation of this type of marking.
Correct. That'll come out with, as Angela mentioned before, the pavement design guide material that we've been putting together in conjunction with the design office. So whenever that all gets finished, that'll be placed somewhere, and I'm sure it'll be known to the world, whether it's through bulletin memo or something. So.
All right, and this last slide on the audible and vibratory markings just shows some photos of the process used to install the ground-in rumble stripes. So you'll see on the left how the ground-in part is carried out first, and then on the right how the actual marking is applied on top. With that, I'm going to hand it over to Raj, who's going to take us through traffic signals.
Thank you, Angela. Thank you, Chris. Well, when we started thinking about this particular presentation, we were really thinking that we should focus on the three aspects, namely signs, pavement markings, and traffic signals, because that is usually what most of us would like to touch on when we think of traffic control devices. Kind of following the same format which Chris and Angela did, which is to begin with the MUTCD, which is where everything begins when it comes to traffic signals and all traffic control devices. I strongly encourage any colleague working with traffic control devices to take a peek at MUTCD, because there's a wealth of information in there, particularly on signs, pavement markings, and traffic signals. There's also railroad crossings and work zones and so on and so forth. But essentially, from a traffic signals point of view, MUTCD specifies various criteria that need to be followed, including a signal model analysis. But before coming to that, let me first touch on the Manual on Uniform Traffic Studies. Though this is not exactly and directly related to the presentation today, it is worth going through the Manual on Uniform Traffic Studies, which is available on the Florida DOT website. And the reason why I'm highlighting this is because anything we do in traffic engineering and operations needs to be done through a comprehensive engineering study. And the MUTS manual provides a comprehensive assessment of what needs to be done in terms of studies. And one of the most integral chapters in the MUTS is with respect to conducting signal warrant studies. And that's the reason why I thought it is important to mention about the MUTS manual. As a matter of fact, the MUTS manual is going through an updated version now. It's being revised as we speak, and probably the final version would be available by the end of this year, if not January of 2015. Having said that, basically Chapter 2 of the MUTS manual provides a comprehensive assessment of conducting traffic signal studies. Coming back to the METCD, long story short, the definition of METCD is that the definition of a traffic signal in METCD is that any highway traffic signal by which traffic is alternatively directed to stop or permitted to proceed. And also, traffic is defined as pedestrians, bicyclists, and a whole range of modes that actually use a roadway to traverse the segment. So, for purposes of travel, interesting how METCD defines it. It is within this need to assign the right-of-way at locations that we consider the dual purpose of traffic signals. In other words, the intent of a traffic signal is to provide an efficient and safe operation through any highway or any roadway. Traffic signal is not the answer to all the questions because there is a feeling that the traffic signal needs to be there. It just cannot be there. There needs to be a comprehensive assessment through a signal warrant study, which I'll touch on in a minute. The METCD also defines traffic control signals to be, in other words, METCD says we have to be very careful because sometimes traffic signals can be ill-designed. That means the purpose of moving the traffic efficiently and with safe consideration may be overlooked, and that is something we definitely should avoid from any point of view. A traffic control device can sometimes be ineffectively placed, in other words, at wrong locations, which is, again, not something we would like to see. It should not be improperly operated. In other words, a traffic signal should provide, as we said before, the most efficient movement, and that means optimization is one important aspect of running traffic signal systems. A traffic signal should not be poorly maintained because when we poorly maintain, it results in excessive delay. People tend to not to follow the traffic signal if it is not properly placed, and so on and so forth. And this can also lead to a very unsafe situation. On the other hand, a traffic signal, if it is properly divided, if it is properly designed and timed, can actually provide, as we said before, an efficient movement, not just of the vehicles, but also all road users, namely the pedestrians and bicyclists and every other mode conceivable. It effectively maximizes the volume of traffic that moves through that particular intersection. And also it helps to mitigate traffic crashes if we use the right kind of application when it comes to traffic signals. And last but not the least, it improves the accessibility to all modes, including pedestrians, and particularly with reference to side street traffic. And I say that because often we try to improve the progression through urban corridors, and we often tend to forget about the impact on the side streets. As we move towards more active arterial management, which is something that we are pursuing now, definitely the focus is not just going to be on the main streets, but also on the side streets and how to minimize the delay from the side streets. And that's a different topic for a different day, but I thought it's important to touch on that one. From a disadvantage point of view, as I said before, if traffic signals are not properly designed and deployed, they can lead to excessive delays. That can also lead to people not following and, shall we say, disobeying the traffic signal, which means it also increases the use of less adequate routes that are available. And last but not least, it can also increase the frequency of collisions, particularly rear-end collisions. So when we get a request for installing a traffic signal, one of the first things we all have to think about is, if we install a traffic signal at this particular location, is it possible that the rear-end collisions are going to go up? And usually that answer lies in conducting a comprehensive signal warrant analysis. So who initiates a signal? Essentially, any developer who is developing a particular area, there may be a need to provide a traffic signal. So a developer may request one. A city or county may decide that a traffic signal has to go in, and also elected representatives can suggest the need for a traffic signal. Of course, the public also feels that because they're driving through that area, they feel that a traffic signal may be needed, whether it is school zones or in any area. And last but not the least, the Florida DOT regularly takes a look at every single customer complaint and citizen concern, and then decides if in fact a traffic signal is warranted at a particular location. Now, as I said before, at the end of the day, we have to conduct a comprehensive signal warrant analysis before any traffic signal can be implemented, can be deployed, can be installed. There are, METCD prescribes 9 specific warrants. I'm not going to go through a detailed explanation on all of them because we all can go through them, but essentially, if you look at the MUTS manual, the Manual on Uniform Traffic Studies, there is a comprehensive assessment of what should be conducted to do the signal warrant analysis. The first warrant deals with 8-hour volumes. In other words, during 8 peak hours of the day, what is the traffic like? The next warrant relates to 4-hour vehicular volumes. The third one is about peak hours. So we're looking at 8 hours. We're also giving a chance to look at 4 hours. We also want to see what is happening during the peak hours. The important thing to note is that there's also a warrant on pedestrian volumes. So the pedestrian volume may be so high that you may in fact need a traffic signal at a particular location. School crossings constitute an important part of this study. If there's a coordinated system, you want to take a look at it. Crash experience, a very important aspect. METCD says that if you provide a traffic, if there have been 5 traffic crashes during the last, I think, 3 years, and we need to check this one, then you can provide a traffic signal, provided those crashes are susceptible to a correction to the installation of a traffic signal. In other words, anybody who does a signal warrant study is going to look at the crashes, the type of crashes, and if in fact a signal is installed, can these traffic crashes be mitigated as a result of installing this signal? So that is one important aspect that is reviewed as well. The roadway network and of course the intersection near a grade crossing. The bottom line is, even 9 warrants is met, essentially the location qualifies to have a traffic signal. Now, a word of caution, having said that, because 1 warrant is met, a traffic signal may be needed, it does not necessarily mean that you go install the traffic signal. The professional engineer who signs and seals the study has to call engineering judgment into picture and see if in fact a traffic signal is the correct method of treating that particular location. Now, I know that Chris and Angela touched on the traffic engineering manual. So what you see now is a screenshot of the contents from the traffic engineering manual. Essentially, there are 9 subsections within 9 sections within Chapter 3. And as you notice, there's a whole range of issues that are being covered. Everything contained in the METCD is followed, except that we provide a better clarification on what needs to happen with respect to traffic signal implementation and operation in the state. I can pick a couple of important ones, or shall we say, a couple of items that have been of interest during recent times. For example, if we take a look at, say, Section 3.8, that talks about mid-block crosswalk. And the last 5 or 6 slides of my presentation are going to be on this one, so hold on to that thought. Section 3.6 on yellow change and red clearance interval is also something that provides a very direct hands-on implementation process for every single traffic engineer who deals with traffic signal timing in the state. And of course, with increased focus on pedestrianization, the countdown pedestrian signal head applications covered in 3.9 also take center stage. The audible pedestrian signals. Once again, I repeat, it is definitely worth your time to take a quick glance at the traffic engineering manual, because every single section in this manual is written by folks who've done this, who've been in this business for a long time. All the districts and anybody who wants to provide a comment gets a chance to provide the comment. So what you see is the final version that is published on the Florida DOT site, and it provides some very good guidance on everything we do with signing, payment marking, and traffic signals. So the next few slides, I will really drill down into section 3.8 of the traffic engineering manual, just to illustrate how all these things come together, namely signing, payment marking, and traffic signals. Not to go into too much detail, but section 3.8 talks about mid-block pedestrian crosswalks. And we are going to change the terminology from mid-block to mid-block and uncontrolled approach crosswalk. In other words, the next version that is going to be revised in a few months from now is going to touch not just on mid-block crosswalks, but also on any crosswalk at uncontrolled locations. There are some broad definitions contained in the traffic engineering manual. I'm not going to go through that, except to say that the more recent ones, which we all are hearing about, are the pedestrian hybrid beacons and the rectangular rapid flashing beacons, the RRFBs. These are sort of the brand new, if I may say, not brand new, but they've been being applied for some time now, or recent ones in traffic control devices that are being applied. And essentially, pedestrian hybrid beacon is a pedestrian actuated traffic control device that provides a dark indication to motorists until it is activated by a pedestrian. And when that happens, it turns into solid red indication so that the motorist can actually stop for the pedestrian to cross. The rectangular rapid flashing beacon, on the other hand, consists of two rapidly and alternatively flashing rectangular yellow indications with LED arrays in them, which provide guidance to the driver to actually yield to the pedestrian or stop for the pedestrian. Here's a standard crosswalk, which is sort of touched upon in section 3.8. Here's a marked crosswalk. Essentially, you're providing the necessary marking for individuals to cross at an appropriate location. The standard procedure for traffic control devices is that in every single case, traffic control, the decision on installing a specific traffic control device is made at the district traffic operations engineer level. In other words, any request goes to the traffic engineering and operations office in every district, traffic operations office, and they do a comprehensive evaluation and decide on the type of device that needs to be installed. And that is no different with respect to the mid-block crosswalk. Again, Traffic Engineering Manual 3.8.5 talks about the considerations in quite some detail. Again, this presentation is on traffic control devices, so I'm not going to spend a lot of time except to say that there are certain criteria that need to be met before any traffic control device is actually considered. From a safety point of view, I think at the end of the day, the centerpiece to anything we do with traffic control devices is safety. Any traffic control device that will be installed or should be installed needs to be safety. There needs to be safety consciousness when we install any traffic control device. You cannot install a sign on the street and then a tree limb which is shielding that sign. That means the whole purpose of installing that sign is lost. We do not want to provide a traffic signal when there is no need for one or when the volumes are low, and therefore that is a wrong application of a traffic signal device. We do not want to provide payment markings at locations which are not going to meet the safety intent. So everything we do is safety driven, and there is no difference with respect to section 3.8 as well, because there can be requests to install crosswalks anywhere, but then the ultimate driving point is, do you want to install a crosswalk where the pedestrian volumes are so low that at the end of the day a motorist may be surprised seeing one, and therefore there could be a potential crash. Anyway, long story short, safety is the bottom line when it comes to any traffic control device consideration. This is where I think all come together. The Section 3.8, the Traffic Engineering Manual, talks about treatments that can be used. So you can use a special emphasis crosswalk. You can have curb extensions. You have raised crosswalks. You can go with speed reduction treatments. You can go with signing and pavement marking to ensure pedestrian safety. And last but not the least, you may consider a pedestrian traffic control signal if the warrants meet. In other cases, you can consider pedestrian hybrid beacons and the rectangular rapid flashing beacon. Here's an example of a pedestrian hybrid beacon, just so you can see on the left side, and then a rectangular rapid flashing beacon, RRFB, on the right-hand side, on the right side of your slide. Here is another example of a rectangular rapid flashing beacon where you see the LEDs light up when the pedestrian activates the signal. Here's a...
Raj, if I may, if you can go back to 2 slides to the pedestrian hybrid beacon, there's a question in the chat. Someone is asking if there's been any situations where a pedestrian beacon went into flashing red mode and the motorists were confused because they are accustomed to a flashing red meaning stop.
That's a great question. That's an excellent question. This is a good point, Dennis and Anthony. Well, during the initial phases, there needs to be a certain level of education also, in the sense that it can happen, not that it does not happen. It would be incorrect to say it definitely does not happen. And that is where we talk about traffic volume. If you have an adequate pedestrian demand and there is, shall we say, a consistent and sustained pedestrian movement, then the regular driving public, if I'm driving that corridor every day, or regularly I should say, I can guess that there is likely going to be a pedestrian. Now, if I'm a tourist altogether, brand new to that location, that's a different story. The short answer to your question is that can happen, but then the devices have been in use, and there have been safe applications wherever they are being used. But once again, it always boils down to that 95th percentile, 99th percentile driver who may not react in time. Fortunately, we've not had any situations that I know of with respect to any incidents with their use. Does that answer the question, Anthony?
Yeah, I believe so.
Okay. All right. Any other questions before I move on?
There's nothing else in the chat at the moment.
Did you say there is something or there's nothing? I'm sorry, Anthony.
No, there is nothing else in the chat. Thank you.
All right, thank you. So I took these couple of pictures from the FHWA website, which talk about the nighttime crosswalks being illuminated. Crosswalks being illuminated, and that provides a very good application because when you light them, it is easier for the drivers to see. In other words, whatever you can do in terms of traffic control devices to enhance pedestrian safety or any is a good thing. This slide comes directly from the Traffic Engineering Manual Section 3.8. We have refined it last year, and we provided a better definition of what type of device to use in specific applications. For example, let's take the left half of this slide. Let's say the major street volume on both approaches is 1,000 vehicles per hour. And if I move up with that 1,000, and let's say that we have the pedestrians per hour is somewhere around 100. This is a classic example where I'm going to install a pedestrian hybrid beacon. On the other hand, as I said before, once you reach the higher level volumes and the approach volumes, pedestrians and motorists, then you get into the traffic signal scenario. Of course, the Section 3.8 says that the minimum should be 20 pedestrians. So anywhere you're in this region, you go for a rectangular rapid flashing beacon. Once again, don't mean to get too much into detail on this topic here, but just to give you every single traffic control device has some kind of criteria attached to it before it can be used and applied on the state highway system. One last slide before I touch on the wrong way issue real quick, and this is a screenshot from the Plans Preparation Manual, which talks about mid-block crosswalks. And the reason I put this slide up is because there is complete consistency between the various publications which the DOT has. The Plan Preparation Manual, Section 8.3, drills down into mid-block crosswalks, which is consistent with the Traffic Engineering Manual, Section 3.8 on mid-block crosswalks. So you do get guidance from 2 or 3 different sources, but then ultimately there tends to be consistency in all of those. And before I say thank you, since this is a safety academy, I think it's worth mentioning that the wrong-way crashes, not just in the Tampa Bay area, but also throughout the state, have been a cause for concern for all of us. So about a year ago, we started getting into pilot projects. We initiated a statewide study trying to see what best countermeasures should be applied to mitigate the wrong-way crashes. And the most common applications obviously are going to be in the traffic control devices domain. And as Chris and Angela mentioned before, they are planning on implementing the rectangular rapid flashing beacons, which would turn on the off-ramps when a wrong-way detection actually takes place. So not only do we make sure that the minimum MUTCD guidance on the do not enter and the wrong-way signs are provided on the off-ramps, we also want to make sure that we use the traffic signal capability to provide a through arrow in that rightmost lane immediately adjacent to an off-ramp so that somebody does not accidentally make a right movement onto the off-ramp. So this is one visual cue which we think we're going to implement. So a pavement marking front, there are many situations, whether it's Fowler, Fletcher, off of 275, where the leftmost lane would have the left turn arrows on the pavement. But then there's going to be a break because there's an off-ramp coming in from your left-hand side. And then you get into the actual left turn lane to get onto the on-ramp. So we are thinking of making it a standard. It's a bit premature in terms of what we could get into at this point, but then we would like to see that the left turn arrows in that left turn lane would be made into a straight arrow with a wording called ramp or maybe a pavement shield. We're still discussing the various options on the table. So the point I'm trying to make is traffic control devices have an extremely important role to play, not just in guiding the motorists to their destinations, but also in terms of providing adequate safety. The proper application of traffic control devices definitely is going to go a long way. For example, with respect to the wrong-way crashes, we are even thinking of having the do not enter or wrong-way signs maybe 5 feet above the other than 7 or 8 feet, just because we want to put it in the driver's point of view. Of course, if somebody is under the influence, we cannot comprehensively address every single crash, but whatever we possibly can do to get the driver to recognize that there is a particular wrong-way movement, whether it is a sign 5 feet above the ground and not the 8 feet above the ground, or the signs on the left-hand side and the right-hand side on both directions with 2 sets of wrong-way signs, with wrong-way signs on the overhead, with the rectangular rapid flashing beacons warning drivers of a wrong-way movement, or with in-pavement markers that look like a stop line when you try to get onto the off-ramp. So there's many ways of doing this, and I think we're all in it together to make sure that the right kind of traffic control device is implemented, and not too many of those. I mean, sign clutter is always a big concern, because when you have too many signs, the whole purpose of providing a sign is lost. So we do our very best, and I know Chris and Fred, they actively ensure that Chapter 1451 provides the right kind of message and serves the motorists at the end of the day. That's really it. I guess we can go on, but we appreciate the opportunity to be here, and Chris, Angela, and I have done our very best. And Dennis and Anthony, we can open the floor to any questions or anything at this point.
Sure. Yeah. If anybody has any questions, please type them into the chat. We will address them as they come. There was a clarification question on the rectangular rapid flashing beacon wrong-way driving application. You're filing for permission to experiment? Like what stage of the process are you in?
Is that a question, Anthony? I'm sorry.
Yeah, that was the question. What stage of the process? You're filing for permission to experiment to use RFBs for wrong-way driving?
Thank you for asking that question. We have been in conversation. conversation with the Federal Highway Administration. We got one approval, which is the District 3 in terms of the in-pavement lights, the rectangular rapid flashing beacon. I got to double check. We were told that a response would be coming very soon. We'll double check. At this stage, let's assume that it's in the pipeline.
Okay. At the moment, I do not have any other questions in the chat, but I'll give everyone a few minutes to type whatever else they may have.
Sure.
Again, I wanted to mention if anybody is interested in the actual slides for the presentation or a recording of the presentation being given, that will be posted at that TampaBayTrafficSafety.com webpage. So that's where the information, any follow-up questions or whatever will be on there. And if you are looking for those PDH credits, that is the location as well where you download the full fill out to send to Larry Hagan for the PDH credits. There was a question in the chat earlier about needing to sign in, what kind of verification and proof. And we realized that there are people that watch the presentation together in conference rooms. I mean, this is a fairly small world that we live in. So I mean, we know who most people are that are out there. So we do cross-check against the registration and the people that actually attended. GoToWebinar has a really nice report that we get to see, what time you logged in, what time you exited, and whatnot, and we kind of glance at that when those come in for the PDH credits. But I mean, it's an honor system to some degree as well.
This is Dennis. Raj and Christopher and Angela, I want to thank you three for giving this presentation today, and I will kind of turn this back up to Anthony to close it out if there's no other questions.
One more question came in the chat regarding the recessed lights in the crosswalks, in roadway lighting. How long do they last? Do they need to be, batteries need to be replaced? How do those work?
Yeah, Anthony, from what we understand, there's a few variations of that. More and more, I think the solar are being used, but once again, I'm not very sure about the answer to that. I know that some of them are battery operated, some of them could be, yeah, what's that?
APO, QPO.
Yeah, yeah.
The guys in the turtle would be able to.
Yeah, we'll have to check on that one.
Yeah, I know that in District 7, I can think of a couple of locations where they were installed and were subsequently removed.
Yeah,
I believe that they're a maintenance,
correct.
That they're a bit of a maintenance issue. So if you're considering those, they're really cool when first installed, but really give some consideration and do your research on the maintenance of those, because they have been installed in areas that I can think of and they're no longer there.
Right. Just to provide a clarification on that as well, Anthony, you're absolutely right. I think this point needs to be emphasized. Before we install any traffic control device, it is always important to think about the maintenance aspects of it. I mean, delineators is a classic example. I mean, we would like to definitely keep traffic on one particular direction, but then the moment you use delineators extensively, traffic ops job may be done, but then maintenance has to maintain them, and then you can't take away what you install out there. So it's a complicated, it can be a complicated decision, and therefore your point is well taken. Maintenance aspect should be considered. Just one more clarification. I just checked. The RRFP is still in process, so we will let we will let the guys know when it's done.
And question, Dennis, question for you. In the third phase of the Highway Safety, the Safety Academy, someone is requesting a webinar on the strategic Highway Safety Plan emphasis areas.
Okay.
So throw that into the mix of possible topics if it is not in there already. There's specific things to do with them, how they're calculated, what they are, how we address them, whatever the case may be. But that's a good topic. Thanks for that suggestion.
Thank you.
right, and I haven't seen anything else come into the chat anymore. I'm going to go ahead and end the recording. We'll stay on the line for a few minutes in case anybody else has any other questions. Thank you, everyone, for attending, and thank you so much for the great presentation. That was
very good.